The behavior of gases can be understood through the kinetic theory of gases. This theory says that gases are composed of many molecules in random chaotic motion. The temperature of the gas is an indication of the average kinetic energy of the molecules. In fact, the formula for the kinetic energy of the average molecule is 3 halves kT, where T is the temperature of the gas and K is Boltzmann's constant. If you want the total energy of all the gas molecules, you just multiply that formula by the number of molecules. Oftentimes it's more convenient to get the total energy by using the number of moles instead of the number of molecules. Then the formula is U equals 3 halves nRT, where N is the number of moles. Make sure your T is in Kelvin. The other properties of the gas that you should worry about are pressure. Pressure is caused by the collisions of the molecules with the sides of the container. Also, the volume of the container. The volume of the container tells you how much space in the universe the container is taking up. When you're looking at the formulas that relate the volume, temperature, and pressure, the formulas are either PV equals nRT, which works for any gas at any time, as long as we neglect the size of the molecules and intermolecular forces, which is usually a good assumption. Or we could rearrange the equation and say PV over T equals a constant. Sometimes it's easier to write P1 V1 over T1 equals P2 V2 over T2, where 1 and 2 represent two different times when we're measuring the properties of the gas. This formula only works if the number of molecules is constant, so we have to make sure that when we do this we have a closed container. If molecules are able to escape from the container, then P1 V1 over T1 no longer applies.